Hi, this is Mrs. Wade with 8.1 Exponential Models Part 2. Now that you can graph a basic exponential function, we're going to shift them. So we want to try to remember our shifting rules. They're the same rules you've used for parabolas, for absolute value, for square root. None of that's changed, just the parent function has changed. So let's think about it. If I have this function and I add a number to it, let's say I add 2 or something like that. How does the whole graph move? Do you guys remember from before? It moves up 2, and this can be any number. If I take my exponential function and let's say I minus 2, it moves down 2. If in the x part I have a plus 1, that moves to the left 1. And if I have a minus 1 up here, that means it moves to the right 1. So these are all the same. If I have a negative in front, that is a reflection. It's a reflection about the x-axis. Okay. All right. So now that you guys know that, just some basic tips for you. With exponentials, as you know, you always have two main things that are moving. You have your y-intercept that moves, and then you also have your horizontal asymptote that moves. Once you shift those, then you can just sketch your exponential function, whether it be growth or decay, given those basic elements. So the main tip I have for you is to move the y-intercept and horizontal asymptote first. Then draw your graph. So that's just a basic tip for you that I think you'll find useful when you do these. So let's talk about y equals 3 times 2 to the x. If I have this basic function here, we already graphed this on part 1, but we know that 3 is the y-intercept, and that's my b, which is greater than 1, so we know it's growth and not decay. So I have a horizontal asymptote at 0, and then my intercept is at 3, and it's growth. So there's my basic function for that. Okay? Now, on the same graph, I want to talk about how this moves relative to the original problem. Okay? So it has an x plus 1 in the exponent. So if you recall from the shifting rules, what does that mean? It means it goes to the left 1. Now, if it moves to the left 1, does your horizontal asymptote change? No. The only thing that changes is the y-intercept. The y-intercept changes. The horizontal asymptote stays the same. Okay, it stays the same. So the horizontal asymptote is the same, but the y-intercept, instead of being here at 1, it goes to at 3. It moves to the left 1. So there's my new intercept. It still has to be 3 away from the asymptote. That part does not change. So then you just draw the graph. So this one right here is y equals 3 times 2 to the x plus 1. And this is your original of y equals 3 times 2 to the x. How do you think this one moves with the x minus 1? It's got to be pretty similar. So instead of left, this one goes to the right 1. Okay? So the y-intercept changes, but the horizontal asymptote stays the same. Because all you're doing is moving from left to right. If you're moving from left to right, the asymptote doesn't change. So in this case, it goes to the right one. So it's the exact same graph and same shape, it just moves from right to left. That's the difference. All right, now let's look at the other shifting. We have numbers 4 and 5. Let's look at those two and compare them. So for 4 and 5, the exponent doesn't have any change, but it has a +1 there and a -1 there. So remember, this goes up 1, this goes down 1. So this time, the horizontal asymptote does change. It changes. So I would start with the horizontal asymptote and then do my intercept. So for this first one, it has a horizontal asymptote of 0 normally, but it goes up 1. So this time, my asymptote is right there. The y-intercept is still 3. Well, originally, if you look at the top, from the asymptote to the intercept, it has to be 3. Well, this time my asymptote moved. So I count 3 up from the asymptote. Count up from your horizontal asymptote. So 1, 2, 3. So there is my intercept. And then it's 2, so it's growth. So there's that one. Okay, so this is 3 times 2 to the x plus 1. For the -1, this time the asymptote goes down 1. Okay, and then same thing for the intercept, you count up from the asymptote. So 1, 2, 3. So this purple is y equals 3 times 2 to the x minus 1. All right? So when you have up and down, both things move. The asymptote moves and the intercept moves. But the distance from the intercept to the asymptote remains the 3. That does not change. Okay, so now let's look at number 6. This one doesn't move right, left, up, or down, but rather it has a negative in front. So this means it's a reflection. Okay, so normally you have your asymptote here, and I'm going to draw this with a faint, just dashed line. So if that negative were not there, this would be at 3, and then you would draw it like this. That's what it would look like if the negative was not there. But the negative is there, which means you have to take this and flip it. Reflect it about the line y equals x. Right? It's a reflection. So, instead of 3 up, you go 3 down. 1, 2, 3. And I'm sure you guys are good at drawing reflections after our inverse chapter in chapter 7. So that is the graph of -3 times 2 to the x. Okay? So now that you understand the basic patterns, I have 2 problems that I'd like you to try on your own. So while you're watching this, if you could pause it and try number 1, and then you can start it up again and see if you did it right, and then try number 2. Okay, you hopefully have tried number 1, so now I'm going to explain to you how to do it. So first, let's talk about all the shifting that's happening here. This means down 4. This means left 2. This means a reflection. This is your y-intercept, or your distance from the asymptote. That y-intercept really is the distance from the asymptote, either up or down, depending on the reflection. This is your b. Because it's greater than 1, I know it's growth. So let's go ahead and graph what we know. Now, because it goes down 4, I'm going to start here and graph my horizontal asymptote first. So I'm going to go down 4, 1, 2, 3, 4, and that is my horizontal asymptote. Now, I'm going to graph this with a dashed line and pretend it doesn't have the reflection. And then when I'm finished, I'm just going to draw the reflection. You don't have to do it that way. I think it's easier that way. So now the intercept is 4, which means you go 4 up from here. So 1, 2, 3, 4. So normally it'd be here, except you got to go left 2. So I go left 2. So there is my intercept, not of the reflection, of the regular graph first. And then I'm going to reflect it after. You can do it now if you want to. So once again, recap, I start with my horizontal asymptote. The y-intercept is 4, so I go up 4, but then I also go left 2. So that's my new point. If this was not a reflection, I would graph it like this. But it is a reflection. So since it's a reflection, instead of up here, I go 1, 2, 3, 4. I'm down here, and my graph looks like this. So this right here is my graph of the reflection. Once again, you don't have to draw the non-reflection first. If it's easiest for you, go ahead and draw the reflection. But I think some people benefit from drawing the original and then reflecting it, but it's entirely up to you. Here's the second problem. If you want to pause it and try this on your own, I think that's a really good idea. I'll explain it when you come back. Okay, hopefully you've had a chance to try this. Let's go over this. So this goes down 2, this goes to the right 1, this is my y-intercept, there's no reflection here, this is my b, and since it's less than 1, it's the k. Okay? So anytime you're moving up or down, I recommend you starting with your horizontal asymptote. It's much easier that way. So down 2, there's my horizontal asymptote. And then I go 4 up for my intercept. So 1, 2, 3, 4. But then don't forget, you got to go to the right one. So 1, 2, 3, 4, and to the right 1. I went up 4, 1, 2, 3, 4, and over 1. Now, because it's decay, instead of growing up, it's coming down from this side. So you just kind of draw the best exponential graph you can. And so this is your graph of this. Okay, very good. That is the end of part 2.